Thank you for the introduction. Thank you all. Welcome. We're going to have to, not on. Okay. Okay. We're going to have to go to super high frame rate mode here if we're going to get through most of the slide deck. So you're going to see some skipping, synopsizing, etc. To synopsize the first 5 or so slides, the end game here is to get some performance and behavior information out of our gateway networks. What are gateways? For those of you who are not familiar, gateways have 2 HCAs in them. One looks back to, say, a compute cluster, a compute subnet, and the other HCA looks in another direction to our file system subnet. There's no InfiniBand mechanism for bridging between subnets, so that's how you do it. That's the hardware way. And the software magic sauce that pulls all this together is something we call LNet. So there's some concern and interest about what's happening at these gateways. And in order to find out what's happening at these gateways, we're using an earlier version of LDMS, and it only samples once a minute. So I think what was previously discussed is sometimes known as the observer problem, where the process of observing disturbs what you are observing. So we don't see that at all at 1 minute. Not only that, but LDMS is only sampling the 1,200 or so HCAs. It's not looking at the 5,000 plus switch ports. So that further diminishes the possibility of some interference. So the swamp we're trying to drain, the end game is some performance or behavior information on these gateways. And we're using LDMS. And like many of the other things that capture data, there's no built-in analytic tool. So we had to build that. So it turns out the first task will be primarily to basically do a C trial on the analytic tool. And, oh, by the way, maybe look at some things that we think are happening inside the cluster, especially at the HCA level. But we're not absolutely convinced that it is. Now, skimming ahead, whoops. So we pick on our friends Jesse and Susan with IB counters shell script that every 10 minutes goes out and basically does read resets on the 12 data items that it collects. So we know that there's a rhythm that's occurring. We should see resets every 10 minutes. And behold, we do. Every 10 minutes, the counters that we're looking at in this HCA, turns out we're looking at the port transmit wait counters, which on our gateway nodes accumulate counts very quickly. And we see them rise up for 9 minutes, and then the next fetch of data that we get from LDMS has a lower value, so we assume there's a reset. 144 times in a row, bingo. 10-minute cycle on the reset. Our joy, however, is short-lived. Originally, I'd planned to do like 100 of these plots. Unfortunately, this next day plot sort of changed that idea. What's happening? Well, there's 6 occurrences where what we expect to happen hasn't happened. Now, there's a human foible that says if you find data that goes against your belief system, the first order of business is to throw that data away because it must be bad. So you have to resist that. After all, look, it's just a little over 4%, 6 occurrences out of 144 that go against the grain, so to speak. Well, you can't do that, not and be honest about analyzing the data. So there are two possibilities here, one of which is I'll call the avalanche possibility. That is, you come along and for 9 minutes you collect data, and then the reset occurs and the value goes to 0, but the accumulation of new counts continues and you get some count, and then all of a sudden an influx occurs, an avalanche of counts comes in, poof, and the count goes above what you previously had. You look at the data that you collect in the next minute, and you conclude there was no reset. This suffers somewhat from the suddenly at step 2 a miracle occurs phenomenon. The more likely situation is that the author of the reset either forgot to do it or couldn't do it. The author put the reset out on the wire and it fell somewhere in the mix, or the reset did get to the recipient, but the recipient was too busy. So I call this the dropped reset solution. And I think it's probably the more likely of the two. I add this just to show that it's not just occurs in series of 6s. There's kind of an interesting clumping together. And what this is driving toward is that the dropped reset may be a hint at another form of running out of resources, in fact, congestion. And then this is what really causes data analytics people to have heartburn. Yes, I've kind of explained the 2 spikes at the far right, but what's happening to the left? Well, this could be a very well-intended sysadmin who's been told, hey, we have, say, 60 nodes at the end of aisle 14. We need to get those puppies back online. So what do? You poke our friend, the subnet manager, and say, hey, Mav, do your inventory thing, which also causes a reset to occur lower down, I believe. And maybe this very well-intended sysadmin takes a while to get all of the nodes back online. So you do a number of these taking inventory sequences. This begs, and perhaps we can get this listed in the think tank best practices area, that when something like this happens, when you get some anomalous behavior like that may be caused by a perfectly normal process within the operations crew, that somehow we tie that back to the data that's being collected, whether that's IB-stat feeding Splunk or LDMS. Because something like this will cause your data analytics person to have a severe case of heartburn. Okay. If these reset drops are only on port transmit wait, we probably would say, who the heck cares? And it turns out it happens elsewhere. Here we have receive data and transmit data, and you can see that they have resets every 10 minutes. However, over here in the unicast packet transmit count, we've missed one. So we've had a reset drop there. So resets drop not just for port transmit waits. All right. Well, I can't say that I have a deep belief in, is this a VL15 being dropped, or is this some other packet being dropped? But whatever's being dropped is a subtle indication of resources running out, and I call that another form of congestion. It may not be as rigorous as the port transmit wait or port transmit discard, but it's something that you might want to seriously think about cleaning up. As we get larger and larger clusters, subtle indicators like the dropped reset might be something that grows to be more and more important to look at and cure. So going back to port transmit waits, again, where do we get them? Well, this is a slide that can be duplicated for all of your, 12 login nodes, your 24 admin nodes, however many you have, or your 1,200 compute nodes. There's only one place that we have where we find and can harvest port transmit waits, and that's here at the gateway node. Someone was bringing up earlier, you can't tell what's happening in general. And here, from the HCA down here, that's the inside HCA that basically points back to the compute cluster. When it does a write, it could be a write to its partner HCA, or it could be a write back to the clusters because it's responding to a previous read that has now been satisfied, and it now has that data that's coming back from the read, and it's writing back to the originator of the read. Port transmit waits. We talked about dropped resets, and those were in the handfuls, maybe not even that many. But here, and for those of you who don't have 25 vision, that's e to the 8 at the upper bound of the y-axis. So these port transmit wait counts are not small. Of course, they accumulate probably at the basic gigahertz rate of the little CPU in the HCA. Although there is some difference of opinion in exactly what a port transmit wait count is, it appears to be more that you have something that you would like to send, you can't because you don't have enough credits, your QP partner hasn't gotten the message through to you that you can now send, so you sit there and block. There could be no one underneath you in your virtual lane. Or you could have requests underneath you in the queue that could fire off and transfer data quite easily. Okay. I'm going to skip over this in the interest of time. Point being that our friend that collects the data in perf query, I believe, overlooks port transmit wait, so we can't get a second source, unfortunately. We do have, well, I'm skipping these. Now, finally, we get to what we would think of as the meat, the swamp that we were trying to drain. We've gotten rid of the alligators. Here we have 37 days of data. We can see A in blue. That's from the perspective of the HCA on the inside, on the compute subnet side. It sees more write bytes than read bytes. But interestingly enough, the read seems to kind of follow along whatever's happening at the writes. Now, we could take this a little bit further with this kind of graph and get the average for both. But that really doesn't tell us a whole lot. What you need to do is to get a statistical process control effort applied to, say, the write bytes, which is what this chart is. This is basically the data from the previous slide, but just the write bytes. And it says that there's an upper control limit and a lower control limit, cut to the chase. And if the data stays within those three standard deviation boundaries, and you don't change anything like add a new task to the job mix or take a whole bunch of nodes out of service, that the future follows the past. And this gives you a very powerful tool for prediction. Now, the previous two slides combined tell you a lot, but each of them crushes some information because it compresses a whole day into a single data element. You probably would not have guessed that this is what a single day looks like to a single HCA. The data arrival, and therefore the data that has to be pushed out, is not even. There are spikes. And you might think about that when you're designing or you're trying to reconfigure. So I'm going to suggest that all three really help you get a three-dimensional view of what's happening at the I/O level. We see spikes. Maybe you want to think about either trying to backtrack who's causing that. Is that a system foible, so to speak, or is that a ill-written user code? Is that somebody just going along every once in a while and doing a checkpoint? So we have this subtle indicator that the reset drops. That is, you can't absolutely guarantee that you get a reset every 10 minutes. And those resets being dropped are an indication of resources running out, or I would say a very, very soft indication that you have some sort of congestion. And then you have the more direct, which is the port transmit wait counts, which are quite high. Note, we have not seen any port transmit drops. The next higher level severity on the switches, we have seen that captured by IBstat and Splunk in the switches. Well, what can we infer from some of this? Well, one of the things is if we get more memory by having more gateways, that might help. It would certainly increase the amount of VL15 and also user traffic buffering in memory. We can also add more memory per task. So, the last summary, a plea that we really need better analytical tools as we get more complicated systems. It could be that several subtle, silent indicators of, say, congestion, if they occur at the same time, almost a stacked tolerance thing, that could be, instead of interesting or a nuisance, it could become an insidious situation. So we need a very, I would say, expert system-based data analysis tool that can chew through A, a huge amount of data, but B, also look more than just counting bytes, that can put together a plausible scenario for these things may not look important, but you should look at them kind of conclusion. So I'm going to ask people to help us try to find out which things to look for, what are the things that we're not looking at that we should consider monitoring, and what are the tipping points. Please come and join us in the hunt for these values, and as Steve Jobs would say, and one more thing. We have some LDMS version 4 data. LDMS will celebrate its second anniversary at about 3:30 this afternoon, Mountain Time. It will have been birthed for 2 whole weeks. So this is a baby picture. Now, it's only an hour's worth of data grab, but you will notice a couple of things. In this series of slides, reads are there are more read bytes than write bytes. And this would initially seem to go against that first slide way long time ago that showed the red and the blue traces, wherein we said, hey, writes historically seem to have been more numerous than reads. And the catch here is that this is not the inside HCA. This is the file system HCA that we're looking at. So it should be the exact mirror image of its friend, the inside HCA. So you would expect it to have more reads than writes because its friend is sending more writes than reads. And on that happy note, I will say thank you. Now, if there are questions, you must submit to the following requirement. There are tins of Hatch chili here. If you ask a question, you have to take 2 tins of Hatch. We have a batch of Hatch over here. So consider that when asking questions. You have to take 3 if you don't ask questions. Are we sure? Yeah, yes.
I was a little surprised by the number of port transmit wait counters that you are seeing. So we have like some small clusters back at a higher state. We have not seen that getting incremented that very frequently. So, and I've checked with folks at TAC and all, and even they don't seem to get this port transmit wait bumping up so much. So is there something specific to the applications that Sandia is running which is leading to such a high value for port transmit wait?
I wish I could answer that. Historically, we've looked at this one cluster, which is not SkyBridge, for a while using LDMS. It's always had a very high port transmit wait count, and only on the gateway nodes, never on any other node. Now that doesn't mean that they don't occur. It's just that after a lot of looking, we have not seen that. It does seem to be annoying.
Yeah, I agree on that.
And adding more gateways may diminish that, should diminish that.
Sure.
I mean, intuitively.
Sure. One other question. So you mentioned that IBMON on this cluster is resetting the port counters every 10 minutes or so, right? Since LDMS is already reading the counters, can't you just make it do a read reset and not, let's say, just disable IBMON altogether?
Well, we could do that. I think the operations crew would probably stone us. Why? Because that is the normal process, is that that is the only thing that we change is the frequency of running IBMON. It currently actually is running every 5 minutes.
Okay.
And that's something we might want to think about of backing off to 10 or 20.
Sure. All I was trying to say is that you could reduce network traffic since LDMS is already running on the node and it is anyway doing a read of the HCA counters. Like you could avoid duplicate effort. That's about it.
Yeah.
Thank you.
I'm a little bit surprised that you have so many transmit wait but no drops. So are you sure that the HCAs actually report would report any drop?
Oh, yes.
Or is it just the counter is 0 all the time?
The script is a hack. So That's always possible that it's not reporting things correctly. But
No,
it does,
I'm
but
like-
it does go through and look for 27 values returned every minute.
I'm not like
Okay.
saying that the script is wrong. I'm just saying that maybe the firmware is just reporting 0 all the time because the HCA itself wouldn't collect or wouldn't expose the counter.
It could be that
So-
the hardware is not being completely truthful
Yeah,
with
yeah.
you. But we do see port transmit drops reported in the switches.
Oh, okay, but the HCA doesn't.
We have not yet. I mean, but who knows?
Okay.
I can't say that we've analyzed every possible day, et cetera. And
because we
with
had-
version 4, things may change.
We had some old hardware which basically wasn't reporting the counters accurately
Uh,
at
what-
some point. So
How old was that?
I don't remember.
okay.
Sorry, it was like
Okay.
DDR, QDR timeframe.
Well, this is a QDR system,
okay.
so
Maybe it's a firmware issue. I don't know.
it could be.
Yeah.
Could be.
Thanks.
So those are like, I think, 6 tins of hatch chili. Is that all? Any comments? Okay. I'll return the clicker to its proper owner.